bunch of you had problems with the exception lab. So I'm going to go over another example for it and try to explain why the way I suggested in the other example is the right way to do it, and try to discuss some of the issues that students had in their assignments. First of all, we got to consider a couple of things. One of the things that we have to consider is that any class we create may be used in a bunch of different places. So that's kind of hard to demonstrate because we're not developing gigantic systems. We're doing little lab programs that contain a few classes and do their thing and so on. But a student class, for example, could be used all kinds of places where students do things, right? Students apply to graduate, students enroll for a class, students pay their bills, and so on. And therefore, we have to really accommodate all those situations. Students might be processed in a batch job, that is, collect a group of transactions and process them all together, like maybe when bills are sent out. All right, that doesn't require interaction with the screen, but that requires something to loop through all the students and do something. So the point is that these classes can be used in a lot of different places. And what does that mean? It means that we need to be careful about two different things. One of the things is where we throw the exception. And the other thing is where we catch the exception. All right. Now, we're going to throw the exception as soon as it happens because we don't want bad or invalid data in our system. Okay. I had a student or a couple students, for example, that tested if a course had negative credit hours when you added it to a student. Well, that course object could be created with a negative amount and used in all kinds of ways before it gets added to a student. So that isn't the appropriate place to test for the error condition. The proper place to catch it is wherever that field is initialized, wherever that field gets a value. And generally that's going to be two places. It's going to be the constructor and it's going to be the set method. So the answer to where we're going to put our code to catch the error is two places, the constructor and the set method, because those are the two places that this attribute can get a value. All right. I'm talking about the kinds of exceptions we talked about before where there's like an invalid value for something. So that's where we're going to be throwing the exception. Now, as far as catching the exception goes, you don't want the class itself to catch the exception because depending on the classes used and what kind of program the class is used, different things might happen. We sort of use as a catch-all to do system out print ln to print to the console. But in reality, we would want to do a bunch of different things. We might want to display the error on a screen. In one case, we may in another case want to display the error in an error log, and so on. It all depends on what program is actually using that object and getting the error. Therefore, we're going to catch the exception where we're going to catch the exception in the class that is calling our class, that is using our class, that is setting the values to our class. So in our case, that will typically be the unit test. Now, one thing about the unit test, well, we'll talk about that later. All right, let's go on and let's do this to the pizza example I think that we had around week 4. So here we go. We have our unit test class, our pizza class, our order class. I'm going to just create one exception. I'm going to create an exception for if they've entered in the wrong size for pizza. So I said we want to do that check in two places. In the constructor and where the set method, where that actually gets set. So I look down here, I have my set size method. So I want to do it there. I also want to do it in these constructors. Now we've learned a lot since this example was in class. So I'm going to change this around to sort of work our new and improved way. All right. We're going to use constructor chaining. So if I call a constructor with one argument, I'm going to call the constructor with 3 arguments and default 2 of the values. Or actually, I'm going to call the one with 2 arguments and let that one default the value. So I'm going to pass arg size and thin to the 2 argument constructor. And I'm going to then if I call this one and only give 2 arguments, I'm going to use those 2 arguments and set has pepperoni to false. All right. I'm getting rid of duplicated code here. I wouldn't want the pepperoni to default for false in one of these constructors and not in the other. So therefore, I'm chaining the constructor. If I call it with 2 arguments, if I call it with 1 argument rather, it calls the 2 argument and defaults the crust. And then that calls the 3 argument constructor. If I call it with 2 arguments, it's going to default pepperoni to false. So in any case, this is a constructor that gets called. Now, I'm going to do something else that's important too, because I want my validation code to only be in one place. So I'm going to put in my pizza constructor, instead of setting the variables directly, I'm going to call the set method. And we'll see that in a minute, the benefit of doing that. It's following the principles of don't repeat yourself. If we didn't do this, if we kept it the way it was, we would have to write that code there and up here in the constructor. Now we could throw potentially exceptions for any of these, maybe. We're only going to do the one. But we have the benefit of not repeating any code. So we don't repeat the code that says that if we don't give us whether it has pepperoni or not, that we default it to false. That code's only in one place. We don't default where we are setting the crust, the the crust type to thin if we don't give that as an argument. It's coded in one place. And we chain up the constructors to finally call this function. Now, I'm deliberately going to put an error in here. In fact, let me get rid of this. We'll see the error that that causes if we don't have that there. Now I'm going to put my check here. So I'm going to say if not, arg equals small and not arg equals medium and not arg equals large, then I'm going to throw an exception. This could be a little confusing, this logic here, but I'm checking for the list. And if all three of these are true, it means it's not equal to any of our valid values. If one of these is true, whereas it is small, then not is small will be false, and this if statement will be false. It's kind of like a double negative here. So if it's not equal to S, and it's not equal to M, and it's not equal to N, then we have an error. If it's equal to any of those values, then the not equals is going to be false, and therefore this if statement will be false. So I'm going to say throw new exception invalid size. All right, let's compile this, and we are going to get some errors. I know that in advance. So I like to say that so students don't think don't know what I'm doing. I will cheerfully admit to any errors that I do make, but I do want to let you know that I know there's going to be errors in this case. So it goes and it tells us cannot find this pizza. Yeah, I didn't intend for that error to happen. Okay, now we're getting the, oh, no, why not? How do I do that? Getting a brain freeze here. Java, another constructor. Oh, just say this. makes more sense. All right. Now, in this case, we have not said that this function calls throws an exception. The compiler is smart enough to know that if you're throwing an exception, something has to handle it. So therefore, this throws an exception and nothing in here handles it. So we have to say, okay, pass the exception on to whoever called this function. Now we're going to compile again and get an error here. So we have to identify that this constructor can throws an exception. Because the constructor calls the set method, and if that gets an exception, the constructor doesn't have any code to handle it, so therefore we have to identify that it also throws an exception. Well, by association, since these constructors are chained, we have to do that for all the constructors. We have to say that there's a chance when this function gets called that there's going to be exceptions. All right, now we're getting that error in the unit test because we're calling the stuff in the unit test. We're calling these constructors in the unit test, but we don't have any try-catch blocks in there. So the unit test is where we're going to put the code. And we're going to put the code to handle the exception in the unit test because we might want to do different things at different times. So therefore, in the unit test, I'm going to edit it. And I'm going to wrap this around in a try-catch block. So I'm going to do all these statements in a try block. I'm not dealing with specific kinds of exceptions, so I'm just going to catch exception E. So because this guy calls a constructor, that potentially throws the exception. Therefore, this code must be in a try-catch block. And I can output simply E and get the message. Now, whenever it gets that error, it's going to stop executing the rest of the try block. So if it gets the error on this constructor, it's not going to go ahead and execute any of these because we have an invalid pizza object. So we don't want to do anything with that pizza object because we know that it's based on invalid data. So what I suggested for you is to put each use case in its own try-catch block because you want to do all your test cases no matter what. And if you put all your use cases or test cases in one try-catch block, the first error it gets, it's going to stop doing the rest of your wait a second, the rest of the error checking.
I dropped my earpiece.
Oh. So we want to do all our test cases all the time. So therefore, each test case is going to be wrapped itself in its own try-catch. Because it will stop executing as soon as that exception is thrown. So we're going to do the same thing with this. Now know that when we do this, we're declaring these classes or objects inside the try block, which means they are not available outside the try block. Now, that might require some ordering things around a little bit differently. In fact, what I'm going to do is I'm going to put all this stuff in our first try-catch block. Because this is a whole, constitutes one test case. We're creating two pizzas and adding them both to the order. Now, it's important to test when something goes right and when something goes wrong. So if I left it as this, it would test, and I think it would show that it works. Okay, it worked, but you got to test to make sure your exception trapping works. So therefore, I'm going to mess up one of these. And it blows up right off the bat. And again, it doesn't execute anything else. So let me try to summarize. Catch errors as soon as they occur, as opposed to waiting around for something else to happen. That means set methods and constructors for the kind of invalid value exceptions we're looking for. There's other kinds of exceptions to be sure, but that would be one common kind of error that you would catch on the set and on the constructor. Throw the exception out of the class and let whoever called it handle it, and do that with the try-catch block. All right, I was out last Monday and I gave a recorded lecture about our first GUI example here. What I'd like to do is spend a minute looking at that and then move on to a second example. Java first GUI. This is a simple Fahrenheit to centigrade calculation. We type something in. We do the conversion. We type something in that is not valid. We get an error message. Let's spend a minute looking at that example. This one, everything is self-contained in this one class. This is kind of rare. That's why this was our first example. We declare all the things that we want on our GUI. Labels, a text field, a button, and a JLabel. And we're using Java Swing components. These are the older style of components to use. Our main simply creates the first GUI object, and our constructor sets the GUI visible. Notice that this extends JFrame and implements action listener. So we could call methods on JFrame like set visible, set default close operation. Here we're creating a panel. A panel is things where we put other controls so that we can position them on the screen. Here we're saying the button, called button convert, action listener is this. That means that the code in the action perform method gets called on this object whenever someone clicks the button. We had our label and text box for temperature, our button, and our label for results. We add that panel to our content pane. We set it up and we open. It sits there and looks at us until we type something in and type the button. Then this kicks in. Inside a try catch block, we parse the input as text because that is a text box. It contains text and the screen isn't on. Is that what you're saying?
No, I just had a quick question. So
Okay.
this is not going to save any of the.
Correct.
And the next question is there any way to, because this reminds me so much of like a Windows application you would see on your desktop.
Right.
Is there any way to make it a shortcut so that way when, like if you created something that can just double click on it and the GUI would just pop up? Or is that like further down the line?
We will talk about packaging this later on. Yeah, that's later on in the course.
Okay. Oh, you didn't have to turn it on. I joined your class.
Yeah, I just noticed that now. I do that just to save energy if I'm here by myself.
Okay.
All right. Let's look at the second example. This is the same thing. However, I create a second class. This is called an inner class because this is one of the rare times that we're going to actually have a class inside a class. Many of you have done that throughout the semester. I've said, no, one Java file per class. Well, this is an exception to it. And it's an exception to it because we're going to put our listener, the code that listens for the button being clicked, or waits for the button being clicked, in the same file because those two things are linked together, right? The GUI isn't any good without the button, and the code that gets executed when the button is clicked, the button clicked logic isn't any good without the GUI. So those two have to go together. And functionally, it works pretty much the same way. Except I have two buttons. I actually did two different ways here. So I type in 22 centigrade to Fahrenheit, Fahrenheit to centigrade. All right, let's take a look at this code. Same thing as before. The only difference is notice that in the previous example, we said that our first GUI implements action listener. You don't remember that? Let's look at it. This is from our first example. Implements action listener. What does that mean? It means it can be used as an action listener. So any place that an action listener is allowed, this can go. So one place an action listener can go is on a button's action listener. I can give this object because this object implements this. What does it mean to implement an action listener? It means that you have a function that looks like this. An action perform function that accepts an action event. In this one, we don't do that for this class. So we have to come up with our listener different ways. So here's the way we do it. In one way, I have this inner class called C to F. And it's defined as a class inside this class. Like I said before, this code, this button code has to exist in tandem with the GUI. The GUI without it isn't going to work. It without the GUI isn't going to work. So there's no sense in putting them in separate classes. But here I create my own little class that implements action listener, and then I give that class the action perform method. And here I use what's called an anonymous class, where I create an object that is of type action listener, and here is its action perform method. And I do that without giving this class a name. So this should be reviewed from last time. It doesn't matter to me which method you use, as long as you get your buttons clicking and code being run. Let's now look at today's example. And I hope to get through as far of this as I can in the remaining time. Here's a fun one. We have a little high-low game here. And our high-low game has classes associated with it. We have a dice class and its own unit test. We have this high-low game and its unit test, and then we have the GUI. This high-low game is a very simple dice game where you roll a pair of dice and you predict whether the value is going to be low, 7, or high. Low is that the pair will be 2 to 6, 2 through 6, the sum of the two dice. High is 8 through 12, and 7 is exactly 7. So we have our class here for our dice. And it's simple. Dice has a face value, and I know it should be die, a singular dice is die, but that sounded unnecessary cruel. So I have a dice as here as a class, and it has as an attribute the face value, the value that's being displayed. I then have, when I construct it, I roll it, and I can also roll it, and that randomly sets the value of the face from 0 or from 1 through 6. Then I have a get that displays the face value without rolling it. How do I know this works? How do I know that this is a good, valid class? Let's say we're working on this high-low game together. Maybe one of us will be working on the GUI, one of us will be working on the dice class, and one of us will be working on the game class. Well, if I got done with my dice class, I want to make sure it works. How can it work? I develop a little test class that counts how many times I've rolled a 1, 2, 3, 4, 5, 6 with the dice. And I roll the dice 10,000 times. And based on what I roll, I use the switch statement to catch 1, 2, 3, 4, 5, 6 and tally them up. When I'm done, I output all of them. Well, guess what? If I have one that gets, in out of the 10,000 rolls, if I have one value that gets 3,000 and another one that gets 20, then maybe there's a problem with my dice object. All right?
Can you leave that up to just random?
Well, what we're doing is we're checking to make sure it really is random. It's by rolling it a bunch of times, right? Because this dice has a random function in it to randomly generate it. What this does is this makes sure that, hey, we're going to roll it 10,000 times and make sure that that each number is showing up a good number of times. So let's look here. And I'm going to run dice test. Now, again, if you flip a coin 1,000 times, it's not going to be 500 and 500. All right. It might be 510 and 490. It might be 520 and 480. But it's not going to be 800 to 200. All right. Then it's really not random. So I run the dice test. And I look and, well, they're all in the 1,600 range. This one's a little higher. This one's a little lower, but they're all within a reasonable range. So I could do it again if I want. It's getting pretty consistently that each one of them gets around 1,600 and maybe one of them gets in the 1,700s. So I'm pretty sure this is valid. I do the same thing with my high-low game. I create a high-low game. Where I guess, is it high, low, or low, high, or 7? And I make those numbers 0, 1, and 2. So if I pick low, the choice is 0. If I pick 7, the choice is 1. If I pick high, the choice is 2. So right here on my play method, I check and I throw an exception if it's not valid. I roll the dice, I get the sum. I look and see if I pick low and the sum is less than 7, then I get paid back whatever I bet. If I pick 1, means I picked 7, I get paid 4 to 1. Now that's deceptive, right? Because not deceptive, but that's showing that in this game, the bank has the edge, right? Because when you roll it, 1 out of 6 times it's going to come out a 7, yet they're only paying you 4 to 1. And likewise, they pay you 50-50 odds for here. I have code that tests that to make sure, gee, does this work fair? high-low gain test. And again, I play some games and I look at the results, and I'm manually going to go in and look. I actually played 100 games. And I randomly picked whether I picked high, low, or 7. This one, I rolled an 8 and I picked high. I bet 1, so I got paid 1. That's good. This one I rolled a 4. I picked 1, which was 7. I bet 1, and therefore I lose. I picked is above 7 and I rolled a 3, therefore I lose. I picked above 7 and I rolled a 7, so I lose. I picked a 4, I rolled a 4 and picked 7, I lose. I picked 8, I rolled 8 and picked above 7, so I win. I picked 8, I rolled 8, I picked 7, so I lose. So I'm going to go and I'm going to check all of these to make sure they're all right. To make sure that all the test cases work. Like right here, I rolled a 7, I picked that it's going to be a 7, I bet 1, and therefore I get paid 4 to 1. So now, I've done a successful user unit test. I've tested the dice, I've tested the game logic. I'm now going to write the GUI. And the GUI is going to look like this. And that's probably the more interesting part of this. I have 100 points, I can pick low, and I roll an 8 or 9 rather, so I lose. So I go down to 99 points. I pick 7 and I roll 8 again, so I'm down to 98 points. Let's pick high, play. I won, back up to 99. If you play this long enough, you will lose because the odds are stacked against you. You're extremely lucky, exactly.
I have a question.
Yeah.
So when I tried to play the game, my dice weren't showing up. I was using IntelliJ.
Okay, it's because of the file path to that. Yeah, the file path to that.
It worked just fine. It's just you couldn't see the
Right.
dice.
Right. And that gets a little confusing. If you email me the code, I can take a look at it and try to show you what it would need to be, but it relates to the path that the files are in. All right, so let's spend a few minutes looking at this code. Got all this stuff in here. High-low, again, extends JFrame and implements action lister. Because it implements an action lister, what does it need? It needs this method. Action performed, that accepts an action event. I have all my labels set up here and different things that are going to be on the screen. I make the frame visible. I say close when it ends. I create a panel. Create 2 panels actually. If I run this, we'll see. This is going to be one panel. This is going to be another panel. I add to the top panel the label for points. I add to the second panel the label for make choice, the option list, and the play button. I add to my first panel again, the second panel, and then I add the label for the results after I play once. When it's clicked, I create, I've already created 2 dice objects somewhere. No, I don't need to do that. That's right. The game has the 2 dice objects.
So it shows you all your, at least your win, your lose ratio. How would you add or
We'll talk about that in a minute here, because we are kind of winding up. I spent a little bit of time talking about exceptions, but essentially we're adding all these to different panels, and we're adding those panels to this screen. Adding another panel for the dice. We have a label for the dice. We add to that to panel 1, that dice panel. We set the layout to be a box layout along the y-axis. That'll be vertical. We set the content pane to that panel that we added all those things in, and then we say go. Now, I have a function to set the point label, and when the button is clicked on, it initializes these variables. It gets the value from the drop-down, subtracts 1 for it, so it makes it 0, 1, and 2. Assumes we have a bet of $1. Calls the game play function that we've created. We've created our game object. It calls the play function. Sees if they got a payoff or not, to see if they've won or lost. Adds the payoff to the points, just redisplays the points. And this is the logic that gets the image. So in your case, with using another tool, you would have to change the way it's getting the path and store it in a different place within your project. We'll probably spend a little bit more time on this next time. I do want to point out 2 examples, one of which was asked about in class. The question was, what if I want to scroll or something like that? This scroll pane Java will show you how to do that. And you can download it and run it. And I think it just shows a scroll. Every time you hit the button, it displays the time in a scroll panel. Then if you want to use radio buttons, this is how we use radio buttons in this example here. So we'll spend some time about this next time, which I don't mind doing because we're a little bit ahead of the game. So we will talk about these in more depth and go over them, put the microscope to them a little bit next time. Any other questions? Okay. All right. We'll either see you in lab or we will see you next week.